So let's start. Number 10, the Watcher effect. Fire a single electron at a barrier with 2 openings and no observer present. That electron does not pick one slit. It passes through both simultaneously, spreads as a wave across space, and creates a ripple pattern on the screen behind the barrier that can only exist if the electron interfered with itself. Scientists call this an interference fringe, the mathematical signature of a particle that occupied multiple positions at the same time. The math predicts it, the equipment confirms it. This is not a theoretical curiosity. It has been replicated in laboratories around the world. Add one sensor, place it at one of the openings, not to block it, not to alter the physical path, just to record which route the electron took. The interference pattern disappears. The electron stops behaving like a wave. It becomes a particle, picks one slit, and lands in one spot. The apparatus is physically identical. The only variable that changed is the act of watching. Scientists removed every human element to check whether the detector hardware was responsible. They ran the sensor with no readout, no recording, no data going anywhere. The pattern still vanished. The electron was not responding to the machine. It was responding to the bare possibility that information about its path could exist, not the hardware, not energy transfer, just the condition of being detectable. This has been repeated with photons, with complete atoms, and in 2022 with molecules large enough to photograph under a microscope. The outcome has never changed. Reality before a measurement is made is physically different from reality. After one is taken, observation is not a passive act. It is a physical event that alters what it observes. No physicist disputes the data. Not one has produced a mechanism that explains why it happens. The universe operates differently when unwatched, confirmed by laboratory data replicated thousands of times in dozens of countries. The detector introduces no force, no energy is exchanged. The only thing that shifts is whether the path is, in principle, knowable. That informational condition alone is sufficient to change what the particle does. We do not know why. Number 9, time running backward. In 1978, physicist John Wheeler sketched a thought experiment. Could a quantum particle's past be changed by a choice made after the fact? Could a decision made in the future reach back and alter what had already happened? 30 years later, a team in Paris built the hardware to find out. They fired photons at a double-slit barrier and positioned a detector capable of identifying which slit each photon had traveled through. The critical detail: the decision to activate the detector was not made before the photon reached the barrier. It was made after by a quantum random number generator that triggered in the final microsecond once the photon had already passed through the slits. The results were not ambiguous. When the detector was switched on after the photon had already traveled through, the photon behaved as if it had always been a particle going through one slit. When the detector stayed off, it behaved as if it had always been a wave going through both, retroactively. Whatever the final measurement showed is what the particle appears to have been doing before the measurement was made. It is like developing a photograph and finding that the act of developing it changed what was in the frame before the shutter clicked. In 2019, researchers at Australian National University confirmed the same result. A measurement made in the present determines what a particle did in the past. Causality, the principle that causes come before effects, that the past is fixed and the future is open, is not a law of physics. It appears to be a preference. Under controlled laboratory conditions, it breaks. The future reaches back and edits what already happened. Multiple independent teams have reproduced this result. The past at the quantum scale is not settled until something in the future determines what it was. Researchers found no experimental design capable of circumventing the effect. Every setup, every variation returned the same answer. There is no version of that finding that leaves time intact the way most people understand it. Number 8, the impossible crossing. Classical physics draws a hard line. A particle without enough energy to cross a barrier stays on the near side. That is not an approximation, that is supposed to be an inviolable rule. Quantum mechanics violates it on a calculable schedule. This is called quantum tunneling. To understand how real it is, stop thinking about laboratory instruments and think about the sun. The sun generates energy by fusing hydrogen nuclei in its core. Those nuclei carry positive charges and push each other away with enormous electromagnetic force. The core temperature reaches 15 million degrees Celsius. Even that is not enough. The thermal energy of the protons at that temperature is roughly 1,000 times too weak to push through the electromagnetic barrier between them. By classical physics, the protons should never fuse. The sun should produce no light. You would not be here. What actually happens is that the protons tunnel through the energy barrier and fuse anyway. The photons released by that fusion travel 150 million kilometers and warm your face every morning. Quantum tunneling is not a laboratory quirk. It is what keeps the sun burning. Every radioactive decay event in the Earth's crust is a particle tunneling through a wall it cannot classically cross. The transistors inside your phone work because electrons tunnel through insulating layers that should, by every classical rule, stop them dead. This is not a phenomenon at the fringe of physics, it is load-bearing infrastructure. The operating rules of the physical universe contain a clause that allows matter to pass through barriers it cannot pass through by any classical calculation, and everything from stellar fusion to modern electronics runs on that clause being real. The rule that solid means solid does not hold at the quantum scale. A wall is not always a wall, and that fact is not an exotic edge case. It is the reason the sun rises. Number 7, the instant connection. In 1981, physicist Alain Aspect ran an experiment that Einstein had spent his final 2 decades arguing could not produce the result it produced. 2 particles were entangled, their quantum states linked so that measuring one instantly determines the state of the other. Aspect separated the particles and measured one. The other particle at a distance adopted the complementary quantum state. Not after a delay. Not after a signal traveled between them. Instantly. The time gap between measuring one particle and the other responding was below the threshold of any possible communication, even at the speed of light. 0 lag. Think of it this way. 2 particles are prepared together and sent in opposite directions. No matter how far apart they are, when you measure one and find a particular state, the other instantly settles into the complementary state, not after a signal travels between them, but simultaneously with no physical connection. Einstein argued there had to be something hidden inside each particle, a preset instruction, that determined the outcome in advance. John Bell designed a mathematical test for exactly that hypothesis. The test showed that no hidden local instruction can account for the data. The correlations are too strong for any local mechanism to produce. In 2017, a Chinese team confirmed entanglement across 1,200 kilometers using a satellite relay. No delay, no carrier signal, no mechanism connecting the particles. In 2022, Alain Aspect received the Nobel Prize in Physics for establishing that this is a property of reality, not experimental error. 2 particles separated by 1,200 kilometers share a quantum state that resolves simultaneously the moment either is measured. Physics cannot account for what connects them. The connection is confirmed. The mechanism behind it has not been found. Every alternative explanation that has been tested has failed. The universe allows coordination across any distance with no delay and no carrier. Physics has no framework for that. Number 6, the calibrated universe. The standard model of particle physics contains 26 fundamental constants, numbers like the strength of gravity, the mass of the electron, the cosmological constant, and the fine structure constant. These are not derived from deeper equations. They are measured in laboratories and written into the theory by hand. What makes them genuinely strange is what happens when you adjust them. Change the fine structure constant by 4% in either direction, and stars cannot form. The universe drifts through eternity as a cold, diffuse gas with nothing inside it. Change the ratio of electromagnetic force to gravitational force by 1 part in 10 to the power of 40. A 1 followed by 40 zeros and atomic structure collapses. No atoms, no molecules, no chemistry. Change the cosmological constant by 1 part in 10 to the power of 120, and the universe tears itself apart in the first fraction of a second after the Big Bang. Nothing has time to exist. Physicist Paul Davies worked through the probability of all 26 constants independently landing within the narrow range that permits complexity and life. The number he arrived at is not merely small, it does not appear anywhere in nature. It carries no physical meaning to give it some shape. Imagine throwing 26 darts blindfolded at 26 separate targets, each the size of a single atom, spread across a surface the size of the observable universe. You would need to hit all 26. That is the order of precision the 26 constants appear to represent. 3 explanations have been seriously proposed: a creator, a multiverse in which all possible constant values are expressed and we happen to occupy a habitable one, or some unknown form of physical necessity. None of those is conventional physics. They are metaphysics, philosophy, and speculative mathematics, each dressed in borrowed scientific language. 26 numbers that should be arbitrary are not. No physical theory explains why. Number 5, the missing majority. In 1933, Swiss astronomer Fritz Zwicky measured how fast galaxies at the outer edges of the Coma cluster were moving. The math did not work. There was not enough visible mass in that cluster to generate the gravity needed to keep those galaxies from flying into open space. They were moving far too fast, but they were not flying off. Something was holding them, something that emitted nothing detectable across the entire electromagnetic spectrum. Not visible light, not radio waves, not X-rays, not infrared, not ultraviolet, not gamma radiation. Every instrument returned silence. In 2006, the Bullet cluster removed all reasonable doubt. 2 massive galaxy clusters had collided. The ordinary matter, hot gas made visible through X-ray imaging, was concentrated in the center of the collision zone, slowed and tangled by the impact. But the gravitational mass, traced by the way it bent light from background galaxies, was distributed in 2 separate clumps ahead of the gas. The gravity had separated from the matter. Whatever produced that gravitational field passed through the collision as if ordinary matter offered no resistance at all. Scientists call this dark matter. It accounts for 27% of the total mass energy content of the universe. Specialized detectors built specifically to capture dark matter particles, Xenon-1T, Lux, Panda X, have returned nothing. No particle, no signal, no trace of any kind. More than a quarter of everything that exists in the universe is made of something we cannot find, cannot detect with any instrument, and cannot describe using any current model of particle physics. We know how much of it there is. We can map where it clusters. We can calculate its gravitational effects with precision. We cannot tell you what it is made of, what particle category it belongs to, or why every instrument ever built to find it has come back empty. The majority of the universe is something we have no name for. Number 4, the catastrophe that didn't happen. Quantum field theory is the most precisely tested scientific theory ever built. Its predictions match physical measurements to within 1 part in a trillion. No framework in the history of science has achieved anything near that level of accuracy. It also predicts something that should have prevented the universe from existing. The theory says that empty space is not empty. At the quantum scale, virtual particles constantly flicker in and out of existence across all of space, generating a background energy field called vacuum energy. This is not a theoretical abstraction. The Casimir effect measures it directly. Place 2 uncharged metal plates close together in a perfect vacuum, and they are pushed toward each other by the pressure of virtual particles forming between them. The force is measurable. It has been confirmed to within 1% accuracy. The energy is real. Physicists then use the equations of quantum field theory to calculate how much vacuum energy the theory demands. They compared that figure to the observed expansion rate of the universe, the only way to measure actual energy density in space. The theoretical prediction is 10 to the power of 120 times larger than what the observation shows. That is a 1 followed by 120 zeros. If the vacuum energy were anywhere near the value the equations demand, the universe would have been annihilated in the first instant after the Big Bang. Every particle ripped apart before atoms could form, before chemistry, before anything. The natural response is to assume the theory is wrong. But the same equations that fail this prediction are the ones that succeed at every other test, to within 1 part in a trillion. The most precisely accurate scientific theory ever built predicts a value for empty space that makes reality physically impossible. Reality exists anyway. The gap between that prediction and that observation is the largest discrepancy in the history of physics. Nobody can explain why the universe survived its own equations. Number 3, the deeper wave. In 1927, physicist Louis de Broglie proposed something the conference room was not prepared to hear. Particles always have definite positions. They are real, localized objects. What makes them behave strangely is that they are guided through space by a real physical wave, a wave that carries information about every boundary, every opening, every detector condition in the experimental setup simultaneously. David Bohm expanded the idea formally in 1952. The physics community mostly dismissed it for the next 50 years. Then, in 2006, Yves Coudert and Emmanuel Fort at Paris Diderot University built something that forced physicists to pay attention. They placed oil droplets on the surface of a fluid vibrating at a precise frequency. Each droplet generated a wave on the surface as it bounced. That wave then guided the droplet's next motion. The droplet wrote its own wave. When those droplet and wave systems were run through a double-slit arrangement, they produced interference patterns. They demonstrated tunneling behavior. They followed orbital paths that arrived in specific quantized sizes. A fully classical system. No quantum equations, no probability amplitudes, just fluid dynamics and surface waves reproduced every defining result of quantum mechanics that had baffled physicists for a century. The implication deserves careful attention. Quantum strangeness may not be the fundamental layer of reality. It may be the visible surface of something deeper, a deterministic wave structure that carries complete information about every particle to every location simultaneously. If that is true, then the randomness and uncertainty we call quantum mechanics is not fundamental at all. It is a shadow cast by a level of reality we have not yet learned to observe directly. We may have been studying the projection for 100 years and calling it the wall. What sits behind it may be deterministic and fully classical, operating at a depth we have not yet reached. The oil droplet experiment does not prove this, but it shows, with physical objects you can see in film, that quantum behavior can emerge from something entirely classical underneath. That possibility is not settled. It is open. Number 2, quantum life. Quantum coherence is extraordinarily fragile. When a quantum system holds superposition, the capacity to exist in multiple states simultaneously, even the smallest contact with its environment collapses it almost immediately. Thermal noise destroys it. At room temperature, quantum coherence in most systems lasts for femtoseconds. 1 femtosecond is 1/millionth of 1/billionth of a second. Warm, wet, chemically active environments are the worst possible conditions for sustaining quantum effects. Hold that. In 2007, Graham Fleming's team at Berkeley discovered that photosynthesis, the process by which plants and bacteria convert sunlight into chemical energy, achieves nearly 100% energy transfer efficiency by exploiting quantum coherence. The light energy absorbed does not commit to a single path through the photosynthetic complex. It explores every possible route simultaneously in quantum superposition and finds the most efficient one. It does this in warm, wet, biologically active tissue at room temperature, in exactly the conditions that should make coherence physically impossible to sustain. The efficiency it achieves is beyond anything a classical mechanism could reach under those conditions. In 2011, a separate team confirmed that European robins navigate by quantum entanglement. A protein called cryptochrome sits in the bird's retina and contains pairs of entangled electrons. Earth's magnetic field collapses those entangled states at different rates, depending on the bird's orientation relative to the field. The bird reads the difference as a directional signal, a compass built from quantum entanglement operating inside a living eye at body temperature. Either our understanding of decoherence, of when and how quantum effects collapse, is fundamentally wrong, or evolution independently solved the problem of sustaining quantum coherence in conditions our best physics says are impossible. Both options carry serious implications. Life is running quantum computation in hardware our equations say cannot function that way. We do not have an explanation for how. Number one, the absent observer. Physics can describe the behavior of everything. Every force, every particle, every field interaction, from the smallest measurable unit of space to the edge of the observable universe. Physics has an equation for it, a model for it, a mechanism for it. There is one thing it cannot describe. The thing doing the looking, consciousness, the bare fact of subjective experience, the sensation of being present to anything at all, has no entry in any physical equation. Philosopher David Chalmers named the reason the hard problem of consciousness. It is not a problem of complexity. It is a structural gap between any physical description and the bare fact that there's something it feels like to be a person. You can trace every neuron involved when you see the color red. You can map the electrochemical cascade from your retina to your visual cortex in complete molecular detail. That account cannot touch why there is an experience of red at all. Mapping every wire in a building tells you nothing about whether anyone is home. The physical description and the fact of experience are different in kind. In 2023, the largest adversarial collaboration in the history of neuroscience brought together dozens of researchers from rival theoretical camps to test the two dominant theories of consciousness against experimental data. Both theories failed. After 30 years of coordinated scientific effort and substantial funding, both came apart when tested. Researchers did not announce they were getting closer. Several concluded the field had moved further away. Every other item on this list is something out there behaving wrongly. This one is different. Consciousness is not a glitch in the universe. It is a glitch in the instrument we use to detect every other anomaly on this list. It produces no measurable signature. It appears in no equation. The universe generated a process that experiences itself, and the best physics ever written cannot find that process anywhere in the math. That is not a gap waiting to be filled. That is a crack running through the foundation of what we think we know. That's it for this one. More is coming. Subscribe so you catch it. See you in the next.